Okay, so this is another question about rate of reaction. Okay, so as soon as you see the word rate here, remember you're talking about the speed of the reaction. So you're thinking about how quickly things happen. So it's usually involving something to do with time. Okay, now this time it's between calcium carbonate, which is those little marble chips, those little chunks of rock, and hydrochloric acid. Okay, and this is what the student has used. Now sometimes, just focus that again. Sometimes it might be drawn with a gas syringe. Okay, this equipment here is basically just to collect and measure the amount of gas that's being given off. Okay, so even though it's using a different method, it's still collecting and measuring gas. So there might be this setup, there might be a gas syringe in there. So you just need to identify that these reactions really are trying to do exactly the same thing. Okay, so in your flask, you've got the calcium carbonate, which is the little rock bits, and then you've got your hydrochloric acid. It follows up through the tube, and then you've got bubbles of gas being produced. So you are measuring in here the gas that's being made. Okay, so it's collecting the bubbles and it allows you to measure the gas that's being made. And it's to do with how quickly it is, because it's to do with a rate of reaction experiment. So the student recorded the volume of gas, okay, because volume is a much better word than amount, every 5 seconds. Okay, so that will help us with this, the speed idea, this rate idea. And then they did it at different temperatures. Okay, now rates of reaction experiments, you could be asked about different temperature, you could be asked about different concentrations of the acid, you could be asked about different surface area. Okay, so there will be one thing that they've changed in the experiment. In this case, it's temperature. Okay, now the equation for the reaction is CaCO3 plus 2HCl gives me CaCl2, H2O and CO2. Now, do not ignore in an equation these symbols, okay, because it tells you a lot, and sometimes they will ask you specifically about the equation and the clues are there. Okay, so this is S for solid because that's our little rock chips. I've got a solution of acid that makes a solution of calcium chloride. It makes water, which is a liquid, and this carbon dioxide, which is a gas. Okay, so if they said to you, how do I know that there's a gas being given off? I can say, or it might say, well, what is the gas? If I look for that G, it tells me what the gas being produced is. Okay, now there's lots of information on this question. So they've put their results onto a graph for 20 degrees C and 40 degrees C. And those two temperatures are labelled on here. Okay, so I've got the time in seconds. Please read the axes on the graphs. Okay, because you need to usually use them. Right, so this is time. This is to do with the speed or the rate. Okay, and the volume of gas being produced. Okay, so you can see that as time goes on, in both cases, the amount of gas increases. Okay, so they're both giving off gas over time, right? So it says use information from figure 2. Okay, so you have to use the graph. And it says state one conclusion the student could make about the effect of temperature on the rate of reaction. So if they're looking for the effect of something, they're looking how is it different? What did it do that made it different? Okay, so in this case, I'm going to look at my two different temperatures, right? And I'm going to say, well, which one is faster? That's all it's looking for. Okay, so I can either say a general conclusion. So the higher the temperature, I've only got two temperatures, the higher the temperature, the faster it goes. Or I can quite simply say 40 degrees is faster than 20 degrees. Okay, so the reaction at 40, because it's a steeper line there, a steeper curve, is faster than it is at 20 degrees. Okay, so that's your overall conclusion. It then says, give one reason, and I've kind of pointed you in that direction already now, Give one reason why the student could make this conclusion. So you've got two options. You can either say the 40-degree line is steeper, which equals faster. Okay, so steep line equals faster. Or you can remember that the reaction finishes when that line levels off. So 40 degrees C finishes the reaction first. Okay, so that's another way that you could use the graph to actually explain how you know that 40 degrees is faster. So for this part, I know that you could tell me that, but you just need to think, well, how did I know that answer? Okay, so it's a steeper line, or it finishes and levels off first. So I'm just gonna, I'll put that on there, so it levels out. Okay, right, now the next little bit is asking us to explain in terms of particles and collisions the effect that increasing the now this is asking about a different thing, so it's asking about the surface area would have on increasing the rate of reaction. Okay, so basically what this is saying is that if I had these chunks like this and I made them into chunks like, ooh, I can't write on my piece of paper, chunks like this, what effect would it have? Okay, so these are large chunks, but they've got a small surface area. Okay, so these are small chunks, but they've got a large surface area. So a large surface area, these ones, reacts faster. Okay, so that's how, what I've said, how it would affect it. That's because there would be, so because, now I'm going to use these two words because things can only react if they collide. Okay, so the reaction can only take place if the particles collide. If there's all this surface area here, the particles are going to bump into it much more quickly. So there would be more collisions between the particles. Okay, so you need to come up with whatever it's asking you, whatever the thing they've changed is, how does it increase collisions? Because the more collisions there are, the faster the rate of reaction. So in this case, the bigger the surface area, the more collisions there would be between the particles. In this case, with the temperature one, the reason that 40 degrees is faster is because the particles are moving more quickly, so they've got more energy, so there's more collisions. Okay, so whatever the factor is that they've changed or they're asking you about, it's basically you just need to describe how come there would be more collisions, because the more collisions you have, then the faster the rate of reaction.